So now we're finally to the point where we can factor higher order polynomials using synthetic division. I decided to go with this later example so that you can try it out with the earlier example if you need to. So let's take a look. We have to verify a few things. The first thing that I noticed is that they are telling us some information about the polynomial, meaning when they say P of 2 equals 0, when x equals 2, your polynomial value equals 0, or we could say P of 2 equals 0. What that is giving you at this moment, it's giving you the root, or 0, or x-intercept. So that's telling us x equals 2 is a root 0. In other words, x-intercept. So different ways to say this. So I just want to make sure you're clear with that notation. Now, what's cool about this, if you know in fact that you do have a root, then you will have a factor. So by the factor theorem, this is going to tell us that x minus 2 is a factor of your P of x. That's by the factor theorem. So basically what I'm doing is if I already know who a root is, it's always x minus whatever that number was. So if you had a -2 as a root, then it would be x minus a -2, which would be x plus 2. But we just have x equals +2 as a root. That's the only thing we're given. So that means x minus 2 is a factor of P of x. So I'll set myself up at this moment just understanding this. My P of x, which was equal to -6x cubed minus 17x squared plus 63x minus 10, it in fact factors down as x minus 2 times something else. And that something else happens to be the result of the synthetic division. It's the quotient part. So we'll get to that. But at least you kind of understand with just this information, you already kind of have an idea of where this problem is headed. It also gives us indication in the directions, which I love. They're asking us to use the synthetic division, so this is going to be useful. So let's take an idea. When they tell us P of 2 equals 0, they're giving us the idea that we could kind of invoke the remainder theorem again, that whenever you do get a 0, you end up having a factor and a root. This tells us right away that we can use k equaling 2. That's the same thing we see right here. And what we're going to do is we're going to use synthetic division. And I'll take away that arrow so that disappears. To figure out what this quotient part is. So let's just keep in mind when we are using synthetic division, we're always writing everything in descending order and accounting for missing terms if needed. So I do see that we're in descending order, there's no missing terms. So I have -6, -17, +63, -10. So as far as the synthetic division is concerned, first thing we will do is drop the first coefficient down below the bar. And then whatever we drop below the bar, we're going to multiply it with our k. So -6 times +2 is -12. We're going to add vertically -17 plus -12 will give us -29. We're going to take that -29, multiply it by 2. And we should get 58. And it should be a -58. So we'll add vertically 63 plus -58. That's going to give us a 5 below the line. 5 times 2 gives us a +10. And when we add vertically, look what we get, a remainder of 0. And we already knew that was going to happen based on the information of the problem. So that's good. It's verifying everything that we want it to verify. So just kind of keep in mind, if you don't get a remainder of 0, then double check your math. A little bit, sometimes minor computations cause issues, but it should be 0 if you are using this information when the k is 2. You should have a remainder of 0 according to this given p of 2 equals 0. So what this means, we can now take our quotient, and our quotient is, and actually I'll write it in purple to help you out, based on the coefficients. We just divided x minus 2 into x cubed, so we're going to drop the degree down by 1, so we should get negative 6x squared minus 29x plus 5. And that, my friends, is the factorization after you divide x minus 2 into the p of x. So that's how we found our quotient. Now, we're pretty much good to go. Notice there's 2 things to pay attention to. We do have a linear factor based on the information that they gave us with the 0, p of 2 equals 0. But this right here, see if I point to it, that whatever we just found, this is actually a quadratic factor. Do you remember why it's called quadratic? If you said, yeah, the highest power we see is a 2, you are correct. So we have the factorization going on, but when they say factor completely, they are interested in making sure we have linear factors only. So what that means is we have to take our quadratic factor and just see if we can factor it using any of the techniques we may have learned from our past. And if we can't, we could pull out the quadratic formula and go backwards, but usually you don't have to do this in a college algebra course. So let's see if we can factor this using some of the techniques from our past math courses. I'll pull this off to the side. I kind of notice for myself, what I'm seeing is I do see a polynomial of the form ax squared plus bx plus c. It's a trinomial in that nice form. And that gives me a little bit of freedom in what I'm trying to work on. I kind of see that I can use kind of the a times c method. Some of you may notice that if you are using the a times c method, in our case, a was -6 and c is +5. So we do get factors of -30 that add up to the b term, which is -29. I should say the b coefficient. So if you can find factors of 30 that add up to -29, you will be pretty good to go. So I would get, what do we have? 30 times 1. If I need a -29, I need to have a -30 times +1. So this will help me out a bit. Now, sometimes you might be a little bit confused, and I would be too, is that when you do have a negative coefficient, you may not want to go straight to this technique right away. What I might recommend, and it's just kind of hindsight, sometimes I start off and I notice, I don't really want to factor something that has a negative coefficient. You could, in fact, rewrite it, and I will kind of erase this right now, and we'll go backwards a little bit. You could take this -6x squared minus 29x plus 5, and you don't have to, but it just saves a little bit of time. And you could factor out a -1 to begin with to maybe make it a little cleaner. So whenever you factor out a -1, it changes the signs of the terms. So +6x squared, +29x, and then -5. And that could give us a little bit of a nicer factorization. You'll kind of see something differs by a negative sign. But I'll kind of give you a technique here. So, I mean, it is sort of the same idea, except we're getting something slightly different. If we were taking a times c in this case, a times c in this case would still be negative 30, but this time the b would be positive 29. And we'll keep this negative 1 in a second. Don't worry, I'm not getting rid of it. Nothing's changed. But the factors are still the same in a sense. We still have 30 times 1, but if we need to have a positive 29, the negative sign would go here. Now, the reason why I like to do it this way is when I do have a positive x squared coefficient, like I do here, I don't have to worry too much. I can take some shortcuts when I do the factorization. So feel free to factor this any way you like. I will show you my version. I like to use what they call the bottoms up technique. And this usually happens when the a is not equal to 1. It's a little rougher to factor, but not too horrible. We've done this before in our past. So what I like to do is make sure you start off with your chosen factors. And again, our chosen factors were 30 and negative 1. And what you'll do for yourself is you can divide both of those factors by a equals 6. That's where we had our non-1 in front of the x squared term. So if I do that, I'm dividing them both by 6. If I can reduce, which I will, I'll color code it just a little bit. Let's see, 30 over 6, that becomes a 5. And I like to write them as fractions, so I'll say 5 over 1. And negative 1 over 6 doesn't really reduce, so I'll keep it as is. What this in fact gives us would be the factorization, but we would use the idea of what they mean by bottoms up. I know you probably thought it'd be more exciting, but it means you go from the bottom, the denominator, to the top to rewrite your factor in your binomial. So remember, idea is we're supposed to factor these in a product of two binomials. Binomial times binomial. So if I looked at 5 over 1, I would end up having a 1x plus 5 as my factor. But usually if there's a 1, you don't have to write that in front of the x. So I have x plus 5. And then my other factor would be bottoms up. So 6x minus 1. So it's one way to do the factorization when you have a leading coefficient that's not equal to 1. If you prefer to use other techniques from your previous classes, go for it. I just really do care about making sure that you're accurate with your factorization. So there's a technique if you don't have one already. But that takes a little bit of time. So let's go back to the problem. I know that's not the only thing we're looking for. Final idea. Remember, we're trying to factor our polynomial so that we have linear factors only. So let me erase some of the noise here for a second. So let's do this. Remember, when I first factored, I took that negative 1 out of the situation. So what I did for myself is I rewrote it so that I had 6x squared plus 29x minus 5 inside. But remember, when I pull out the negative 1, I have to kind of be careful because who was already there on the outside? X minus 2. So if you were looking at this a little more closer, most of the time when you see constant, or I should say monomial factors, they prefer to write them on the outside. It's not the outside, I should say at the very beginning. And now, my friends, the very last step is to just rewrite the factorization of your 6x squared plus 29x minus 5, and we found it right here. X plus 5 times 6x minus 1. So that's the way I do it. Keep in mind there could be some different versions based on this, this negative 1 factor right here. I believe another appropriate version, you may, if you were doing the factorization, the negative 1 probably factors in here. You might have gotten a 1 minus 6x maybe. with everything else the same. So that would be another version if you were, maybe you factored it a little bit differently than I did, but it's still about the same. Still gives you the same results. So just double check one more time. Make sure that we followed the directions. Number one, did we use synthetic division to factor P of X completely? So a check, we used synthetic division. We found ourselves a quotient. We used the factor theorem to get our X minus 2 factor. We factored a little bit further because we had a quadratic, or we should say more of a trinomial of the nice form. And so when we factored completely, we just want to make sure in both cases, do we have linear factors? So if everyone is a linear factor, we are good to go. And we have just factored our first higher order polynomial down.